So now the second topics we'll do the topic 2 will do the Form 4 chapter 2 atomic structure. So normally if these topics come out in exams, right, they'll ask you about the definition of nucleon number lah. So what is nucleon number? Total number of proton and neutron in the nucleus of an atom. What is proton number? Will be the number of proton in the nucleus of atom. Standard representation looks like this, that you have a symbol here, then you have a nucleon number on top, then the proton number below. So in exam, they might ask you to draw electron arrangement or ask you to draw atomic structure. What is the difference between these two is electron arrangement will be like this, AL at the middle, then all the electron arrangement. Then draw the atomic structure will be the middle is the proton and neutrons. Then, okay, what is meant by isotope? So for isotope, right, is the atom of the same element with the same proton number but different neutron number. Means you can see here that their neutron number is 12, 13, 14 is different. Then the proton number is same, 6, 6, 6. Because proton number determine your element. If you're 6, you're carbon. Then if you are 7, will be nitrogen. Okay, so you're using this to decide your elements. Then, in other words, you can write this also, atom of the same element. Definition, you can either write the first one or the second one. Atom of the same element with the same number of proton, but different number of neutrons. So this is the definition. You either choose 1 and 2, 1 or 2. So number of proton is the same. You can say hydrogen 1, they got 1 proton each. But for the H1 is no neutron. H2, 2 minus 1, you get 1 neutron. 3 minus 1, you get 2 neutron. So the number of neutron is different, but the proton is the same. So you can use the first definition or second definition. But you're not allowed to mix. You cannot just say that same proton number, but different number of neutrons. So if you mention same proton number, you must mention different neutron number. If you mention same number of proton, then you must follow different number of neutrons. So these are similarity and differences. So the proton number is the same, number of protons is the same. Electrons will be the same because proton and electron is the same number. Electron arrangement, same also. For difference will be neutron number difference. So this part is difference. Number of neutron is difference. Okay, because the more neutron you have, you are heavier. So when heavier, density will increase because density is mass over volume. So when your mass increase, your density will increase. Okay, then after that, your melting point, boiling point also increase because your mass increase means you are heavier. Heavier means very hard to boil, very hard to fly to the sky to become gas. Okay, so for the chemical property, because chemical property depends on valence electron. So example, for this carbon, 6 is 2.4, 2.4, 2.4. So all of these have same number of valence electron, so their chemical property will be the same because same number of valence electron means come from the same groups. Okay, then you also need to calculate the percentage of abundance. So very simple in the chemical formula, the calculation formula. This is 28, 29, and 30. 28 is 92%. 29 silicon is 5%. 30 is 3%. So you just take 28 times 92%. 29 times 5%. 30 times 3% divide by 100. You will get the average mass. So this is the average mass of silicon. So the use of isotope will come in the exam also. So medical, we can use copper-60. Copper-60 is treatment of cancer cell. That to kill cancer cell, to sterilize, because copper-60, the radiation is very high, very strong. It can kill whatever bacteria. Then iodine-131 is for the thyroid disorder. Because iodines, they'll go to the thyroid. Then archaeology, you can use carbon-14 as the carbon dating to estimate the age of the fossil artifacts. Okay, carbon-14. Then lead-210 is to determine the age of the sand and earth layer. They're up to 80 years. More than 80 years, you have to use another chemical to test. Phosphorus-32 is to study the metabolism of how whether a plant absorbs all the phosphate fertilizer for us to study. Industry can use hydrogen-3 as a detector for all the sewage liquid wastage. Then uranium-235 is the one that in nuclear power stations in the nuclear bombs. Then after that, engineering, we can use sodium-24 to track the leakage of the pipes. So this is a sample question. They will ask you what is the definition of proton number and neutron number. So you write the proton number, neutron number. Then mention the number of new electrons. So the proton number here means that it's 19, means it got 19 proton. And for atom, they are the same number, so electron will be same. Okay, so the electron will be 9. Then for the neutron, because above is proton plus neutron, below is proton. So to get neutron, very simple, take this one minus, and because you minus off the P ma, then you get your N. 39 minus 19 is 20. Remember to show the steps, just in case. Then for the definition of isotope, you can write isotope are the atom of the same element with the same proton number, but with different neutron number, or you can mention same number of proton, but different number of neutrons. So they want you to identify which two pairs are isotopes. So very simple one, you just find that they have same proton number but different neutron number. So you can mention S and U because atom S and U has the same number of proton but different number of neutron. Then these are all the uses you have to memorize. This is the calculation I showed you just now. This is another type of calculation that you need to know that they have 32, 34. But they didn't tell you the percentage. So they only give you 32.1 is the average mass. So this is what we do. One, we put Y%. The other one will be 100 minus Y because total up is 100. So one is 40%. The other one will be 100 minus 40 becomes 60%. So one is Y. The other one is 100 minus Y. So 32 times Y, 34 times 100 minus Y, divide by 100. You'll get this number. We'll get Y is 95%. So D is 95%. The other one will be 100 minus 95, become 5%. Okay, so look at one sample question that I want you to do on the spot, which is this one. So you can see what is meant by isotope. So you have to write down the definition of isotope. So show the pair of isotopes. So we check here. These two same proton number, different neutron number. So you can mention because they are same number of proton and different number of neutron. So an isotope Y has 8 neutron. We check here. This one got 6 proton, 6 electron. Because proton and electron is the same, you minus off will get 6 neutron. So now they say got another is 8 neutron. So what is the symbol? So now if because above is proton plus neutron. So now my proton plus neutron equals to 6 plus 8 become 14. So your element will become 14 is a neutron number. 6 still will be the proton number. So this is the field that you mentioned. So medical is the copper 60, agriculture is the phosphorus 32, archaeology carbon 14, engineering will be 24, so 24. Then the hydrogen one will be for the industry, power source to uranium-235 to generate the electricity. Then, okay, this one is a percentage. You can see that here is 70 is 20.6%. Then this 72 is 27.4%. 73 with 7.7%. 74 is 36.7%. Then 76 is this percent. So you can just add up everything, divide, you get the average is 72.7%. Then this one same now, they give you percentage is 80%, 10%, but the second one we don't know the number. So same thing is what you do. 80 times 11, 20 times Y. Divide by 100, the average mass is given 10.81 ma. So you put it, then you're able to get your Y equals to 10.05. So you put 10, because normally the relative mass will put a whole number, either 10, 11, 12, 13. Okay, so you just put the nearest number is 10.